Just waiting for my confirmation that everything is working properly. Then we can get the party started. Let me go ahead and hit save over here on the attendant. Because I know we're gonna have more coming. Let me just, they're gonna have to wait. All right. This section we want to do. All right, I'll leave it there. Here, done. Share the screen. Okay, so we're gonna in just about 15 minutes. Oh, okay. So let me see as far as announcements. So today we're going to be working on homework assignments for section 6.2, arithmetic sequences and partial sums. We don't have to work on this homework. I just do this just to kind of fill the air. If you would like to work on something else, just feel free to unmute yourself to gain my attention, and we can we can take a look at it. And we can talk about any assignment, any old homework, quiz, or exam. If you work on an old homework, the best practice is to make use of the ask my instructor and just ask me in class, like, hey, I just sent you an email about this. Can we talk about it? But basically, it's a link that's in Pearson. But anyway, so with that, let's go ahead and just hop into Pearson, and I'll check back for attendance again, like I say, around 2:15. And let's zoom in, because I know this is, for you guys, probably kind of small. Let's see how does this look. Okay. So this first question, so again, this comes from section 6.2, question number 3 from the back of this section. It says, determine if the given sequence is an arithmetic sequence. If it is, find the common difference, right? So the first type of sequence that we've discussed was the arithmetic, right? Well, basically you have some initial term, and then we're adding the same thing each time to each term, right? So if we look at the first term is 3 and the second one is 1. So it looks like if it's arithmetic, then it looks like we've added a -2, right? Because 3 plus -2 is 1, plus -2 is negative. It's like every time we're adding -2. So is this arithmetic? We're going to say yes. Okay, and then the common difference is going to be -2, because that's what we're adding each time. So excited. So like I still got my keyboard from last time. I don't know if I mentioned that. It's like a new keyboard. It has like this backlight, but I'm excited because it has a number pad on it. So I'm total geek, right? But it wasn't working because I'm supposed to be able to connect it to like 4 different devices. So I contacted the company, and they're supposed to be sending me one. It's supposed to be arriving today, so that's what I'm excited. All right, that's just a side note. Okay, so determine it, and it comes in handy when I'm gaming. Like, you stupid mother lover! Like, why didn't you do this? You're supposed to be here. You're a total noob. Just you need that keyword so you can just make them feel it. You go pop, 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 pop. It's not anything. It's just to get some aggression out. Okay. So determine if the given sequence is arithmetic. If it is, find the common difference. Right. Okay. So with this first one, it looks like we added what, -26. And we're not adding the same thing each time, right? Because if we add -26 to -16, we do not get 22. So is this an arithmetic sequence? We're going to say no, because we're not adding the same thing each time. Okay. Let's see. Determine if the given sequence is arithmetic. If it is, okay. So then 0.2, 8 plus what, 5 is what, 13? So 1.3. 2.8, 3.4.1. I think this is yes. And the common difference was, I think we said 1.3. So it looks like we're adding 1.3 each time. Okay. And again, if anything is not clear, feel free to unmute yourself. Determine whether the given sequence is arithmetic. Are we adding it? Okay, let's look at the first few terms, right? So say the first term is like, let n be 1. Then the first term is going to be 5. And then if you let n be 2, 6 plus 2 is 8. So it looks like we added 3, right? Now, if we let n be 3, 9 plus 2 is 11. That's 3. Let's let n be 4 times 3 is 12, plus 2 is 14. It looks like it is. Oh, okay, here. So it says the first term, A1, when n is 1, the output is what, 5, all right? And we should write this out. I was trying to do it in my head. It looks like we're adding 3 each time. Let's look at A2 again. So when n is 2, 6 plus 2 is 8. It looks like we're adding 3, right? When n is 3, 9 plus 2 is 11. And that's 3. Yeah. It looks like there is a common difference. I started to initially say no, but then after I looked at a few terms, it actually checked out. All right, just at first glance, I was tempted to say no, this is arithmetic, but then I was like, let me just look at the terms and make sure. Better safe than sorry, right? Okay. Find an expression for the nth term of the following arithmetic. Let's just confirm quickly that it is arithmetic. Notice that we're adding 3 each time, right? So I think in class, we mentioned something on how to find the general term. Let me see. I think we said that, okay, here, let me kind of take some notes really quickly. Oh. Let's see, this guy. So we're gonna take like this. So be out of shape. I'll probably go for a run after this. Let's go jogging. You jogging? All right. Let's go. Drop this right here. All right. So I want to say in class, we said what? The general term. So then A sub n, I think we said was A1 plus n minus 1 times D. Right? That was define the general term. So let's kind of confirm that the first few cases work for this, right? So for instance, we see that A1 is 6, all right? So then like if we do A2, that's gonna be 6 plus, oh, and we need to find the D. The D is, what did we say, it was 3, right? So then that's gonna be 2 minus 1 times 3. 6 plus 3 is 9. And that one checks out. Okay. Let's do a few more. If we look at A3, that's going to be 6 plus 3 minus 1 times 3. 2, 6, so 6 is 12. That one checks out. Okay. Let me see, 1, 2, 3, 4. Let's just do the next two. A4 should be 6 plus 4 minus 1 times 3. 9 plus 6 is 15. That checks out. Okay. And the final one, A5. 6 plus 5 minus 1 times 3. 12 plus 6 is 18. That checks out. All right. So, okay, so we can have some confidence in this result and submit it. To the time, I'm gonna let the people kind of wait for another about right at 5 minutes before I check attendance. Okay, so let's submit. Let me see. So we got 6 plus n minus 1 times 3, and then we should probably simplify it. Okay. So I think we said this was 6 plus okay. That's it. N minus 1 times D, and D was what, 3 in this case? If we distribute that 3, I'm just going to increase my space. So we're going to have what? If we distribute that 3, we're going to have 6 plus 3n minus 3. So the 6 minus 3, it looks like the final result is 3n plus 3. Okay, it looks like it's 3n plus 3. Okay, let's just check to make sure this works. When n is 1, we get 6. When n is 2, 6 plus 3 is 9. When n is 3, 9 plus 3 is 12, so on and so on, right? So I feel like this is good. Let's go with it. And on to the next question. Use the formula for an to find the general term of the arithmetic sequence. So we need to determine what are we adding each time. So let's get a copy of this. Yeah, let's get a copy of this and take some notes. Okay. Uh-oh. Okay, so that's cool. Uh-oh. Cancel. Okay. So first let's solve for D. So D is gonna be it should be 23 over 4 minus 5. If we get a common denominator, or you can use your calculator. 5 times 4 is what, 20? Like it's 3 over 4. Looks like we're adding 3 over 4 each time. 26 over 4 reduces down 26, 29 over 4, right? So we have our common difference. So then we just said, again, every time we use a formula, it's a good idea to write it down. So the general term for an arithmetic sequence is going to be A1 plus n minus 1 times D. So then our general term should be 5 plus n minus 1 times 3/4. And then if we simplify, let me see the time. 5 plus 3n over 4 minus 3/4. So 4 1/4, 16, 17 over 4. 17 over 4. So this will be 3n over 4 plus 17 over 4. Should be our general term. Again, if anything isn't clear, just let me know. We can talk about it. Okay. And let's confirm this. So I'm going to open up my calculator. Actually, what I'm going to do in my calculator, since we finished getting it to load, I'm going to go to my y equals, and I'm going to put this in as a function. So I'm going to put it in as, there's a couple of ways we can do this. I'm going to do parentheses 3 over 4 x, where I'm just basically letting x be n, plus 17 over 4. Okay. There are several correct ways to put this in. I'm just choosing one. Okay, so then what I want to do is call that function I just typed in. So I'm going to go to my variables. I'm going to go to the right, then hit 1 for function and call on the function we just put in. So for instance, when n is 1, the answer should be 5. When n is 2, I want math as a fraction. The answer should be 23 over 4. When n is 3, we should get 13 over 2. And when n is 4, we should get 29 over 4. Okay. Again, we can have confidence in that result. So then this one. 3n over 4 plus 17. Check the answer. Okay, let's take a moment to check attendance. The stragglers. All right. Edit. Let's see. Let me do this real quick. Okay. All right. Okay. Let me hit save. Record attendance, section 3. And I want today's date. Next. Okay. And then let me go ahead and share my screen again. So if you're welcome, if you're just joining us, welcome. We're just kind of working on the homework for section 6.2. So we've gotten through about 6 questions. Okay, find an expression for the nth term of the following arithmetic sequence. Are we adding the same thing? Okay, let's get a copy and take some notes. So, man, the temperature just keeps changing, like, so. So first, we have the initial term. Let's go ahead and find our common difference, right? So then the common difference is basically the n plus 1 term minus the n term, the n plus first term minus the nth term, right? So for instance, in this case, we could say something like -2 minus -9/7. So then double negative becomes positive, and if we get a common denominator, that's going to be what? -14 over 2 plus, sorry, not over 2, 2 over 1, so 7. Yeah, -14 over 7 plus 9 over 7. What is that? A -5? So it looks like we're adding -5 over 7 each time. All right. So if we say -14 over 7 plus -5 over 7 should give us -19 over 7, then 24, right? So we're adding -5 over 7 each time. So then again, every time we use a formula, we should write it down. In class, we said that the nth term for arithmetic sequence is going to be a1 plus n minus 1 times d. Okay. Oh, also, for that sum of the nth partial sum of an arithmetic sequence, I realized how to derive that. So we'll revisit that, and I'll do it. I did a presentation for my 2 p.m. class last time. I'm going to redo the presentation for you all, but I'm going to do it slightly different than the way I did it for them, right? I think I have a more simple way of doing it than the way that I did it with them. But let's finish this one out. So then if we want the general term, the first term is this -9/7. We're going to say n minus 1, and the common difference is this -5/7. So then we just need to simplify this. So we still have our -9/7. If we distribute, we're going to have a -5n/7 plus 5/7. Combine like terms, I'm going to leave it as -5n/7. What is that? -4 minus 4/7. Okay, let's see how do we do. So we could check these and make sure that they work. Let's check it since we can. Then whenever you can, you definitely want to check it. You don't always have that luxury of checking, but if you can, you should. So if we go to our y equals, we're going to put in negative 5n or 5x divided by 7. And we're going to say minus 4 by 7. You just have to use your parentheses, properly and make sure that you're factoring in order of operations properly and the way you typed it in. And then I basically call them on that function from before. For instance, when n is 1, we should get negative 9 by 7. Then when n is 2, we should get negative 2. And then let's just check a few more. Should get negative 19 by 7. When n is 4, 24 by 7. And let's just do the last one. Okay. So we got negative 5n by 7 minus 4 by 7. 5n by 7, 4 by 7. Okay. Negative 5n by 7. That's annoying. I gotta figure out. I know there's a way to disable that because it wasn't always doing that. And I'm just not really sure how to do that this year. Minus 4 by 7. Okay. And again, if anything is not clear, just feel free to unmute yourself to ask questions. Otherwise, I'm just going to keep plugging and chugging. We'll hang out. We still got a good amount of time. We still got like a solid 20 minutes. Let's keep going. Find the common difference in the nth term of the arithmetic sequence whose fourth term is 5 and 13th term is 41. This is a good one. Let's get a copy. Man, it just seemed like it got warm like all of a sudden. Okay. Okay. So let's start with the general term. So we an is what? A1 plus n minus 1 times d. Thank you. All right. And then they give us a couple of pieces of information, right? So when n is 4, the output is 5. So let's make note of that. So that means we're going to have a1 plus 4 minus 1 times d. The output should be 5. And then when n is 13, the output is 41, right? So we have two unknowns and we have two equations so we can solve. Let's simplify each equation. So for instance, 4 minus 1 is 3. So then we have a1 plus 3d equals 5, and a1 plus 12d equals 41. Okay. So then we can say the first equation minus the second. I'm just gonna switch the orders, or I'm gonna multiply the first equation by a -1 instead, because it just seems easier. If we multiply the first one by a -1, by a negative and then add the two together. So then if we do this, these guys cancel each other out. A number plus its opposite, that's a 0. 12 minus 3 is what, 9? 90. 41 minus 5 is 36. Divide both sides by 9, and d equals 4. So then we can take this and plug it into either equation. I'm going to plug it into the first equation. So if d is 4, then a1 plus 12 equals 5. So then a1 equals, what is that, negative 7? So then it looks like our general equation is negative 7 plus n minus 1 times 4. So then if we simplify, 4n minus 4, what is that? Negative 11. Okay, and we just need to make sure that at least works for what was given. Okay, 4n minus 11. So for instance, when n is 4, the output should be 5. 4 times 4 is 16, minus 11 is 5. When n is 13, the answer should be 41. So 4 times 13 is 40 plus 12 is 52. Minus 11 is 41, right? Okay. So it looks like this works for those. So we got 4n minus 11. So the common difference we got was 4. And the nth term of the arithmetic sequence we got 4 minus 11. Let me check Zoom really quickly. Okay, Mr. Fletcher, you have a question? You still there?
Oh, yeah, I'm redoing the exam. For the plot points, when it says plot points between and beyond the x-intercept and vertical asymptotes, tap y coordinate for each of the following points. Am I just plugging in the x for x? Like it has like, okay. So just do that for each of the x's. Okay.
Yep.
All right. Thank you. That's all.
Okay. Let me see. Let's go to the next one. Find the common difference. Okay, I mean, this is kind of a repeat, but let's do it anyway. Let's knock it out. Okay. Okay. So let's start with the general term. A(n) equals, yeah, this is fine. A(n) equals what? A1 plus n minus 1 times d. And then we're given that the ninth term, so that means we have A1 plus 9 minus 1 times d, and the output should be 2. And then for the other one, 13 minus 1 times d, output should be 1. We have a system of equations. We can simplify. 9 minus 1 is 8. And then 12. With that sound you hear is my dog pacing back and forth. It's driving me nuts. I don't know. I just don't feel well. I totally like this. I'm emotional eating today. And so I'm like feeling it now. I just ate like horribly for breakfast. Just crap. And so like when you get to be older, you know, it hits you so much harder. I mean, it still affects you when you're youth, but when you're young, I mean, I'm feeling it. I was like, ugh. So now it's like I gotta flush my body with like water and just try to just wait through it until it passes. If it passes, because sometimes the older you get, the more it like hits you. Okay. So again, if we subtract, I'm going to multiply the first equation by a negative and then add the two equations together. So that means these guys cancel. I think that's 4D equals, oh shoot, why did I do that one? Okay, well, that's fine. What is that, -1? So then D equals, yeah, divide -1 by 4. So then we take this, I'm going to plug it into that first equation. So then my A1 plus 8 times a -1 by 4 equals 2. What is that? -2. So then add 2. So then A1 equals 4. So then our general term looks like it's going to be our AN is 4 plus n minus 1, and the common difference was a -1 by 4. So then we get 4 minus n over 4 plus 1 over 4. Let me see, 16 over 4. So then it looks like it becomes 17 over 4. And then we just need to make sure that this works for our given cases. So the ninth term, so when n is 9, we should get 2. Let's see, -9 over 4, what is it, 8 over 4? We get 2, so that checks out. And then when n is 13, we should get 1. -13 plus 17 is 4. 4 over 4 is 1, right? So this looks like it works for both. So then we're just going to hop back over to Pearson. What's the time? Let's try to hang out for another 10 minutes. So then we got -n over 4 plus 17 over 4. Negative n over 4. Yeah, for some reason, I don't know why it does that. It's like the numbers lock on or something. It's something that I have to disable and I don't know how to do it. Okay. Plus 17 over 4. 17. I know you gotta go. You gotta give me like 15 minutes. Get down. Gotta give me 15 minutes. Thank you. She needs to go to the bathroom. That's why she's pacing. She's like, oh, I gotta go. Get down. -n over 4. Did we confirm? We confirmed them. Oh, common difference. Oh, shoot. Let me try to copy this so I don't have to type it again. Can I hit all? Yes, copy. Okay, so the common difference we got was -1 by 4. -1 by 4. Okay. The nth term, I just want to paste. Looks good. Okay. Let's see the time. Okay. Find this song. Okay, so this is a good time to kind of let's derive. So we had this formula now. I think I do remember the formula, right? For the sum in terms of arithmetic, I couldn't remember how to derive it. So Sn, I think it was A1 plus AN over 2 and that occurred n times, right? So I want to take a moment to see. Let's try to derive this, and I'm going to try to do this a way that was more simple than the way I did with my other class, right? So say we consider the sum of the first n terms of an arithmetic sequence. So like we're going to add a1 plus a2 plus a3 until we get to an, right? We add in the first n terms. We want to take that same sum and just reverse the order, but we still want to add them up. So it's going to be an plus an minus 1 plus an minus 2 until we get back to a1, right? So if we add these two together, on the left, we're going to have 2sn, all right? On the right, now, if we add column-wise, we're going to have a1 plus an, okay? Now, let me think about it. What's the more simple one? Okay. So now off to the side, I want you to see that what a2 is a1 plus d, right? a3 is a1 plus 2d. Okay. I think so. Let's try to work backwards as well. So then, like for instance, an, I think we said was what? a1 plus n minus 1 times d. So then an minus 1 should be a1. Oh, that's what we did with them. I mean, I guess we can keep going. Okay, if we keep going, this is going to be what? If you have n minus 1, so it's going to be plus n minus 2 times d. And let's go ahead and do the next one. An minus 2 is going to be a1 plus, I think it's going to be n minus 3 times d. I just basically plugged all these into the general form, right? So then if we consider a2 plus an minus 1, if we take what we have on the left and apply it to what's on the right, then we're going to have a1 plus d plus a1 plus n minus 3 times d, right? So then, let me see. So then if we expand this out, I'm gonna leave this first a1. Let's see, and leave this other a1 beside it. If we distribute the d, well here we have n minus 3 plus 1 is going to be, that's going to be the same as plus n minus 2 times d, right? Because I'm basically just adding the coefficients. The 1 from here plus this n minus 3. So n minus 3 plus 1 gives you n minus 2. Let me think. We're almost there. That needs to be an. N minus 1. Oh, okay. I chose the wrong one, right? So n minus 1 right here. It fixes these two guys. N minus 1 is n, this is a 2. And so when we add them together, they give you a 1 there. So I still end up doing the same thing. I thought there was a better way, but long story short, this guy right here, this is our an, right? So then that's going to be a1 plus an, right? So we showed that this guy, a2 plus an minus 1 is just this. Let's do that. Let's do it one more time to show that A3 plus AN minus 2 is also the same thing, right? And then you can show that basically it continues that pattern all the way, right? So if we consider A3, that's going to be added to AN minus 2, right? So then A3, so then this is going to be A1 plus 2D, right? AN minus 2 is going to be plus A1 plus N minus 3 times D. So then I'm just, that first A1, I'm just going to bring down. I'm going to just rearrange the second one. N minus 3 plus 2 gives you N minus 1 times D. And again, this guy here is just AN, all right? Again, this guy here is AN, all right? So all of these combinations end up being A1 plus AN, right? So then basically what happens is this is A1 plus AN. This is really just A1 plus AN. This is really A1 plus AN. And it continues that pattern until you get to the end. They're all just A1 plus AN, right? And then how many times does that occur? That occurs n times. 1, 2, 3, 4, 5, 6, 7, 8, 9, till you get to n, right? So that's where this n comes from. So then basically, I mean, we pretty much got it, right? So this term occurs, that happens n times. You divide by 2, and it gives us this guy here, right? So that was still about the same as, I still feel like there's a different way to go about it, but that's about the same way that I did it with them, and we still got to the same conclusion, right? So the sum of the first n terms of arithmetic sequence is given by what you see in the green at the top, right? Okay, so with that, so I was just trying to get some context. I know that we're out of time. Let me hop back here real quickly. Find the sum. Did we get a screenshot of that? Okay. So let's just finish this last. So find the sum of the following. So this one to about here. Undo. Okay. We're about to wrap it up. So let's just call on that. We just said that the sum of the first n terms of an arithmetic sequence, we said it was A1 plus AN over 2 times n. That occurs n times. Okay. So if we plug in, we need to find out how many terms do we have. So let's take a look at the general term. Again, we're AN is going to be A1 plus n minus 1 times D, right? We have a common difference, so we can find the general term. So then our AN is going to be 5 plus n minus 1 times, the common difference was 6. Thank you. Oh my goodness, stop. Okay. Right? So then we want to solve for n, right? So let's set this equal to 59, and we can solve, that'll allow us to solve for n. So then we get 5 plus 6n minus 6 equals 59. I just expanded or distributed the 6. Let's see, so then we're going to have 6n. That's a -1, so add 1 to both sides, so you get 60. So then n equals what? 10. All right, so there are 10 terms. So then if we want the sum of the first 10 terms, that's going to be 10 times the first term, which is 5, plus the nth term, which is 59, divided by 2. All right, then we just crunch the number. So whatever we get, we're going to say times 5. It's going to be the same as 5 times, what is that? 64. So 5 times 6 is 300 plus 20, so 320. So the sum of the first 10 terms of this arithmetic sequence should be 320. Okay, let's just throw it in Pearson real quick, get our confirmation. You're on about our way. Pearson, we got 320 here. 320. Man, I like the number pad so much. It makes such a big difference. I can type, but it just takes so much more of my attention to type on regular, the keys at the top. But when you have the number pad, you can just, you can feel it, Anyway. Okay. So we got in there. Yeah, so this is a good time. If you have questions, now is the ideal time. If there aren't any burning questions, then we will end the session here. We did 6.2 this week, so then next week we'll do 6.3. The following week we'll be ready for exam 3, and then there's only one more section after that. And after that the supplementary section, we're just going to be reviewing and just kind of, just checking in. Again, the recommendation is this: you definitely want to get your Pearson in order as soon as possible. Again, once we hit that deadline of May 1st, that hard deadline, everything locks out, and the only thing you're going to have access to is the final at that point. All right. So if you need help, you have to speak up. Okay. Or link up with your classmates, link up with the tutors. You've paid for the tutors. So if you don't use them, you're just throwing your money away. If you just want to throw money away, just feel free to throw money into my bank account after you leave my class. All right. I'm not taking bribes. I don't do anything like that. But if you just want to throw money away, you can just throw it my way. Right. But okay, guys. Best of luck. I wish you all the best. And on that note, we're going to end the session here. And from one beautiful mind to another, enjoy the rest of your day. All right, guys. Take care. Peace.